Bala for reminding me for recording. And yes, great. All right, so today we will start from where we left yesterday, and wherever we are talking about in our documentation, let me make notes. So notes have been just now updated everywhere. Okay, so I will make 25 October. All right, so yeah, great. Now coming back to where we left last time. Yesterday, our some of the machines, actually one machine was down, and since I did not have time to fix it, I basically tried to reboot. Great. Now let me close all of this. All right. So these are all required. All right. So yesterday we discussed about the basics of computing. We were trying to solve a problem on the on the sorting of the file. But before that, we were trying to show you how to run a MapReduce job. Okay. Unfortunately, that did not happen yesterday. So let me try to show you that. All right. Let me first open Hue and show you what data do we have. And again, in case you are going through the documentation, okay, so everywhere hadoop1.nobigdata.com has been replaced with h1.cloudxlab.com and Hadoop 2 with h2, okay, or you can say anything with Hadoop, okay, has been replaced like this. Also, Hue is Hue is running at 888 port now, and Vati is running at 8080 port. All right, this is what current system we have. These are some command which I was trying to migrate data. So again, let me just move this to another file, and then we will. Okay, so these are the few changes I'm telling you. Other is, everywhere the username earlier used to be student, it has been replaced with your batch username. You can see this one. All right, keep an eye on this space because this username will keep on changing for you. So also the password is not same password, you have to copy from here. So these are the few changes to what we have in PDF. We will soon be updating in the PDF, but till then you will have to keep an eye on this. Okay, all of this information is actually available here. All right. Okay, so whenever you have to connect to console, either you can SSH or you can do VATI. All right. Also, we noticed that even some of us are not able to log in into this. So the problem with chmod -r dot ssh. So 700. All right, so basically these are the reasons. Sometimes I'll have a look at why are we not able to log in into this. Okay, all right, yeah. So Veena is not able to hear me, others are able to hear me. Okay, great, great. Let me know, because in case there is a problem, I'll shift to another internet connection. Okay, for whatever reason, although this current internet connection is pretty good, but still there is some problem with the connectivity, specifically with GoToWebinar. All right. So yes, now let me try to show you how to run a MapReduce job. Okay. So I'll just describe you what are we going to do. First, I found out this pre-prepared jar file. And what is a jar file? What is a jar file? A jar file is a package containing a lot of code, containing binaries, and it has an entry point. Okay. So jar file is a Java way of DLL, the way you used to have DLL in the what do you call in uh, C++ or Windows MFC. In the same way, Java has jar files. The only difference is these jar files are sometimes executable, meaning they have entry point. So when you compile a Java code, you prepare a bundle of the output. Okay, so this jar file is actually like a zip folder, okay, containing a lot of code. If you actually you can use WinZip to open .jar file and see that it's a basically a folder containing compiled classes. All right, and each jar file has got an entry point. So when you say Hadoop jar, you are trying to execute a program as MapReduce. Okay, now just don't worry about what is MapReduce right now. It's just a way of executing things, executing a program on top of Hadoop rather than on local machine. You are trying to execute a program on the cluster, on the Hadoop MapReduce cluster. Okay, now at this point we are, it's the same Hadoop command with which when we said fs we were interacting with hdfs. Now we are saying jar, that means we are trying to execute a program. So this is our program name. Right now we have just taken an example program provided by Hadoop binary itself. We just used find command to find this particular program. Now the argument, first argument is something which is going to go to this program. This program is going to read all the output, and this is what it expects. It expects one of the, what is it that you are trying to do. So we are trying to do word count, and then input directory. This is our input directory we are providing, and then this is our output directory. Okay, so I've already done mr out. So if we try to execute this program, it should give us an error saying this directory already exists. So you go to your command prompt to using veti, and there you start this program. So it says that the output directory, you can see that the output directory already exists. Yes, output directory already exists. Now you can remove this output directory, and whenever, one more thing you note, there are two ways we are defining a directory. One is absolute location. This is the location where we have put the data in HDFS. All the input directory are in the HDFS, not the local. Similarly, output directory here for any MapReduce program is in HDFS. Okay, also note here the directory name is not starting with slash, which means it will create this directory in our home folder. Let us validate these two parts. One, let's see whether this data exists or not. And if we remember, this is how we can open. If you go to h1.cloudxlab.com, and you can go to this. All right, now this is not your account, so I'll have to log out. Can anybody help me how to log out? All right, this is not okay. How do you there should be it's hidden, I think. Yeah, it's hidden in my go to webinar edge. All right, let me log in into your account. Okay, so this is our login S5665. These logins are automatically created for, we have written a script which create these logins on the cluster for everyone. After some time, these logins will be for individual. Probably probably for next by next week we will have individuals login. Okay, but having individuals login is generally not fun. Most likely we'll have to revert back very soon, because it becomes quite empty, quite lonely kind of hdfs folder, because you don't see other people's folder and then you see, oh, I think I'm doing something wrong. Here when you see, you will get other people's folder as well. Okay, so these are the folders everyone has created here, your whole batchmates. So all right, good. So that's why we have created for the whole batch, but we'll give it a try. Although some people are saying, let's have the single login for the whole batch, but we'll give it a try to have individual logins. Okay. Now coming back to the, yeah, this is my folder, and here let's just have a look at the input data which we are trying to churn. This is our input data. It has exercise wise input data. Okay, and we will use this input data for various things. Let's have one of the examples for MapReduce here. So in my mr folder slash data slash mr, there is word count, and then there is input folder. Inside input folder we have big.txt. Okay, you can see that. Although there is an extra file here, we will just delete it. This big.txt here is just a little confusing, so we'll just delete it. All right. It says permission denied. Oh, because it's a read-only data. Slash data is read-only, that we have to log in from the admin account. All right. Now this also proves that HDFS2 has permissions and HDFS also has roles. Okay. Now, so this file is basically a big text file, hardly 6 MB. This is hardly 6 MB, and we are trying to count the number of words in this. All right. So this folder is what we will give in the input. This folder from here. If you provide a folder, all the files in that folder will be counted. Okay. If you provide to your MapReduce job, if you provide a folder, all the files inside that folder will be counted. All right. Now again, back to my command. Where was that command I was executing? I was executing the command here. Okay, so now it says that the output folder already exists. This mr out is related to your home folder. So let's check if there is, because we are not providing any slash something or some relative path. We are just saying mr out. So it will create mr out in our home folder. You can click on home, and there you will see your home folder. Right, this is your home folder. All right, this is, if you go to sgiri, you will see not sgiri here, mr out. Yeah, here it is. So if we delete this, then it'll be all right. Okay, let's delete mr out. All right, here we go. We are deleting mr out, because in case the output folder exists, the mr job, MapReduce job, will give an error. Okay, so there are few things which we learned from this small exercise. One is that uh, our mr jobs take input from hdfs, put output in the hdfs. So it's a big cycle. So you read the data from a folder, you churn it, then you put it back in the output. If you have multiple phases of MapReduce job, you will have to chain them such that they read from HDFS right to HDFS. Now we have deleted it, so we can start our process. So now I'm running this program called examples. It says that um, the input path does not exist. Let's try to, yeah, that's correct, because here there is word count as well. Yes, thank you, Ravi. You caught the error. Yeah, Naveen Gupta's point is input folder is created using Hadoop make directory command. Is it not a virtual directory? So when we say Hadoop mkdir and we provide a folder, it's basically is a real directory inside HDFS. Okay, I cannot call it virtual directory because it's a directory. It's not pointing to anything. All right, now going back to my folder, is it created here? Let's refresh and check. Okay, is there something called refresh over here somewhere? Okay, so I'll just press home again. All right, here am I out? Yes. So this is the output. And whenever you are doing MapReduce, this is the kind of folder it will create. There will be one underscore success file marking that the job was successful. And also this is our output file containing the output of our MapReduce job. You can see this is basically word count and this is ugly because it has double quotes. We should have cleaned it, and as part of this exercise what we are doing just now, we will do all of this cleaning one step at a time. Okay, when we write our MapReduce we will do a very clean job. Good. So this is what a MapReduce job looks like. So it only did all it did was it did a word count on our big file. Okay, we could, so the important aspect to understand is that we could run this MapReduce example on a file which is even 50 GB in size, while you cannot run such kind of thing using your Java code. Okay, it can run on 50 GB file without any issues. Okay, let me, okay, I forgot to show you. Not here, not here. I'm sorry. So let me minimize it. This is, I think this is better. So you can see that when I ran the job, this is what happened from here. Uh, is the font visible to you, or should I increase the font? Is this good? I think, is this better now? All right, awesome. So moving on, here you can see that this is where we started our job. This is where we started our job. Here, you can see that. Now, it says that the connecting to resource manager, and what is resource manager? The one which is going to execute the job. Just a second, let me grab the mouse. And then it submitted the job with the job ID. Um, it also gave us a URL using which the we can track the job. Okay. Let me give you also a command so that you can also try this at your own. Just change the name of the output folder. Okay, just change the name of your output folder. All right, so here is the command. Let me put it in here and send it to all. So just change this output folder and see what goes on. And it gave us the detailed statistics. You can see this is our URL the on which you can track the job, what happened to the job. Right now, since the process has finished, let me just this is okay, h1.cloudxlab.com, or maybe on h2. Where is this? H3. Ouch. Actually, the IP addresses we have are not good and they need to be changed. Why is it not? Okay, so basically I had to do a lot of hit and trial because I could not figure out the public name for from this kind of thing. We need to change this. We will change it later. Okay, we'll change it later. All right, so it shows us the clearly that there is map and reduce. These many were successful and it is succeeded and all that. Okay, so this is how you run a map reduce job. Now, what is inside a map reduce job and how do you build your own map reduce job is what are we going to discuss today. All right, but we are going to go stepwise. All right, so this shows you all the operations time, how much time, how many bytes were read, how much time was spent, and what happened and what all happened inside. So this is good for diagnostic, and here it shows you the progress of the various processes. Now, Sushant question is, does it also show in case of failure? Yes, of course. And while the job is uh, and while the job is running, it can be like debug. Yes, you can debug your job using this. You can go to map and under this you can go here and see and seek what happened. So here whatever your program is doing std out, all the debug statements will be available here. Okay, so you can say system.out.println and it will appear here. If you say system.out.error, it will appear here. Or in case of Python, if your program is printing to this std out, it will come here. Okay, because for output there are two streams provided by operating system. One is called std out, standard output, or other is called std error, which is for error. So there are two streams to which you can print, and that's what it shows. And sometimes your program might be writing to syslog. Okay, that's another. All right, so we were able to successfully run MapReduce job. Now let's continue our discussion on MapReduce. All right. Any questions? Yeah, Bala's question is, are we going to look at the MapReduce code? Yes. Today we will have a look at MapReduce code and we will also try to solve couple of problems. First, we will go theory and then again back to the hands-on. Okay. So the way we work is first little hands-on, then little theory, then little hands-on, then little theory. Okay. So don't panic in case you do not understand something. Okay, just ask. All right, because whenever you run a new thing there is always a little bit back and forth. So Randhir's question is why it runs only on one split, because it's a 6 MB file. Okay, why did it run on one split? That's a very good question. Because it we will go into the details as well later also, but let me just answer it now. So so the file is only 6 MB. Out of 6 MB, how many blocks will be there? One, right? And thereby, for each block, it's generally one split. Perfect? All right. So we talked about how do you do the word count using your usual programming technique. So the idea was to create a frequency hash table and iterate through the words, count checking in the hash table or dictionary whether we have encountered the word earlier or for the first time, and then increase the count number of times we have encountered a word. And at the end of it, when we finish reading the whole file, we print this dictionary. All right. Good. Now, the other method which some of you had suggested is break the books into one word per line and then import the data, import this one word as one row into the database and then do select word comma count star from the table and group by the word. Okay? All right. Now, the approach number three was, which we discussed earlier, was to use Unix for all of this. Okay, I would like to explain to you these commands. If we'll just take around 10 minutes to explain to you, how many of you are comfortable with Unix filters? These are filters basically. Okay, Sridhar is okay, Pavan is okay, and raise your hand please. Veena is not. All right. Sridhar, Pavan, Saryu, and Naveen is okay with filters, while others need a little heads up. All right. Great. Great. So I will take a bit of time to explain, and I'll not go too much into deep. I'll try to explain in as few words as possible. All right. So great. Now have a look at this. Before that, so here is your command prompt. Okay. Here, if you say ls, it shows the current folder. What happened to this guy? Why do I see? Um, all right, I don't know what is it. Never mind. So if you say ls here, it shows you the current directory. Correct? So ls is a command. Everything here is a command. Now, if we instead of we consuming this output, we can pass this data to another command. Every command can accept the input from you or from the program. Okay, so for example, let's say there is a command called wc. You are typing something, you are typing here something, and you are saying control d. When you say control D, it assumes that you have finished the input stream. So you are the input stream. Your std in is the input stream. So you are providing input and WC is counting. It says that there are 5 lines, 5 words, 38 characters, right? Now the same WC can also take input from another program. Now let's see, can it take the program input from ls or not. So the way you give the input of ls to wc is by saying pipe and wc. The output of ls, instead of coming to you, is going to wc. Now you see, it says there are 3 words, 3 lines, and 26 characters. So instead of you seeing this output, the output has gone to wc, and that's what is piping about. All right. Now, that also means that we can do more stupid things, such as passing the output of WC to further WC. What will be the output? Can somebody suggest now? If I say ls pipe WC pipe WC. All right. 13324. Why 24? Because there is a space in between here. You can see space when I'm selecting things. There is a space. So this is counting the space as well. All right. So this is piping. So you can pipe one program's output to another program. All right. So let us say we have to do the word count of a file. What will you do? Let's try to do it offline. All right, let's try to do it offline. So there is a command. Let me bring this file which we were doing. Does it have the output? Yeah, we have this word count file here. Nice. So we can do cat or tail. Let me just show you tail big.txt. So tail displays only the last ten lines of the file, and head displays the first 10 lines of a file. Okay, so for now, let's just try to pipe this output to wc. You see, it has counted the total words very quickly. All right, now if, let us say, we want to break this file into one word per line, can somebody tell what should I do? Ideally, if this file had been in your editor, in your text editor, what will you do? You will say Control F, and then you will say space and replace it with new line. Same thing, you can use a command called sed. Sed replaces I'll just show you this. All right. So this here means, S means substitute this with this between first slashes to second slashes. All right. So, okay, Ganpati, did you get your answer? There we are counting spaces also here. His question is, how did we get this? We are counting spaces also. 1, 2, 3, 4, 5, 6. All right. All right. So here we are trying to replace space with a new line. Okay. And that's what we are doing. So it will convert this into one word per line. Good. Now, this could be given to another command called sort, which basically sorts anything which is given to it. Okay, and then this is given to unique. Unique minus C counts the unique occurrences of the file. You see that? There are these many new lines, these many blank lines actually, and adventure has occurred. Now we can further sort the output using sort minus nr. All right, you can see that in this small text there are the has occurred 4 times plus twice. We could have done one more filtering here. Before sorting, we could have translated everything from uppercase to lowercase. Okay, now you can see that the has occurred 6 times and so on. All right, in this 10 lines of text. If we want to run the same thing on the full text, we could say, instead of saying head, we will say cat. Okay, so there are so many things it has done. It has done a good counting for us. And if we just want to see what are the top 10 common words, we'll just say head. Now you can see that we have cleverly utilized the command to get our things done. So in this file, the has occurred these many times, 78,000 times, then of, and, to, in, a, the, he, and so on. All right. Now you might be wondering, as Veena is also asking, what is sort minus nr? It means we are sorting numbers. Minus n means numbers. Minus r means descending. We want top, most frequent, biggest number at the top. Sounds interesting? We could do further cleaning up of the data by removing the special characters. We could also have done, we could have removed all the special characters. Something like we could say here SED substitute anything which is not A to Z, 0 to 9 with space. Okay, and that's it. You see that? Now the number of occurrences of the has increased because the might be coming in double quotes or something like that. All right. Now what we have done is I have put an arrow and said WF, which means whatever is the output of all these commands, the overall output goes to WF. Okay. Now if you open WF, maybe using nano, okay, you can see what is there inside this file. Good. Ganpati's question is, where can I find the list of Unix command? Just search for basic Linux tutorial and you will see all these commands. These are very simple commands. All right. Now here is a question. So we saw that why it says that uh, write failed, write error, because here what we did was we we said head. Okay, head means it will just take 10 top 10 words and then say I don't want any more and close the stream, and that's where write stream fits. Okay, all right, good. So that was a crash course of 10 minutes on Unix command lines. So this small thing actually solves our problem. Now there is one more operator I'm using here. This is a very clever operator. Okay, here I'm saying sort minus capital S and 1G. 1G means 1 gigabyte. I'm telling sort command that sort my data and only use 1 gigabyte of the RAM. Don't grow beyond 1 gigabyte of RAM. Now this is a very important switch of sort command. It basically convert this sort command from doing it in memory to doing it in the disk. Okay, instead of consuming RAM for whole of the data, it starts moving it, splitting the data into chunks and do it in the disk. Okay, that changes the algorithm and that changes the strategy of sort command. This is a very important switch, and because of this switch, using sort command you can sort the data which does not fit into the memory. Okay, so is everybody clear now? So we printed the file cat file, meaning this cat command will read the file, put it on the line by line on the std out. Then it will, then the output will of that one will go to std. Std will replace space or tab any number of times. Any number of times. This means space or tab any number of times. It replaces with new line. Okay, and then sorts the lines using only 1 gigabyte of RAM, and afterwards the output is given to unique. Unique only works if the data is pre-ordered. it only works on ordered data. If you try to use it on the data which is not ordered, it will give erroneous results. Okay, so Sridhar, which part do you want me to repeat? And Veena, which one do you say? Where does it say any number of times? Do you mean SED? SED, how many times should it replace? So these commands are operated line by line. All the output of this file is going to SED, all the output, and it's executing it for each line. And similarly, for sort command, the whole input is given as input, and whatever is the output of sort, the whole thing goes to the unique. Okay. So is that clear now, Veena? So basically, it says G. G means globally. No matter how many times this expression occurs. This expression means any number of times, or plus. You see plus here? Plus says one or more times of anything in the square bracket. And what is inside the square bracket? Space or tab. So we are saying any number of space or tab should be replaced with new line. Okay, Sridhar's question is, could you explain minus s 1 gigabyte? Basically, this sorts the data using only 1 gigabyte of RAM. Even if you are sorting 100 gigabyte, it will even if you are sorting 100 gigabyte, it will use only 1 gigabyte of RAM. Okay, it will do the disk sort. Sounds interesting to you? Okay, Veena is saying, do we have option to say first five lines? Yes. So in case of cat, we could say here, if we just want first five lines, we could say head minus five. It will just give me first five lines and then it will pass to SED. Okay. Great questions. Moving on. So this is how we would use a Unix command to do the sorting. Please pay attention to what we had done today. So in case you are not comfortable with Unix, I personally would like to suggest that learn a bit of Unix, because that is probably whenever you are doing any data churning, these tools come very handy. And also, you will be surprised that these commands, what you see here, we can use these commands to do our MapReduce. All right, I'll show you all of this. Now, in the problem number 2 and 3, 2 was using SQL and 3 was using Unix's sort. Okay. All right. One more thing. Can anybody tell me, out of these many commands, how many commands are there? How many commands are there here? How many commands total? Quickly. One, two, three, four. Yes, Pavan, you are right. Total number of four commands. Out of these four commands, cat, sed are the commands, and this is the arguments. So cat, sed, sort, and unique. Out of these four, which one will be most CPU intensive? Which one is most CPU intensive? Correct. Sort command. Perfect. Perfect. And which one is reading most data? I mean, impacting IO. That's correct. It is it is cat, not SED. Because cat reads the file from the disk and hands over to SED. SED just does the line wise editing. SED at a time only get one line to operate upon. Therefore, SED does not consume memory, does not do IO. It only whatever is somebody writing to it, it replaces the one word with another and move on. It does not retain anything. These are essentially filters. Perfect, perfect. All right. And which one might do the writes? This is difficult. All right. So IO is done basically by cat. So Bala, do you want me to repeat the question or which part? Okay, so somebody is writing to the disk in this. Somebody might write to the disk, and who is that? In this command alone. We are not redirecting, Randhir. I was expecting that. Okay, so we are not redirecting. Writes means writing to the disk. This is tricky. Okay, yes, yes, go ahead. Yes, Veena. Oh, Veena can't hear. Can anybody? Others are able to hear, right? Yeah, yeah. All right. Veena, probably the network connectivity on your end is problematic because even if one person is able to hear me, that means my connectivity is fine. All right. Yes, you are right, Bala. Bala is right. It is sort. Because if the data grows beyond 1 gigabyte, sort will create buckets of 1 gigabyte out of it, and then we'll try to sort individual buckets. So while creating these buckets, it might have to write to the disk. Make sense to you? All right. So we talked about two approaches. Approach number two, using SQL. SQL approach is clear to everyone. We are using group by of SQL. And here, so here in the approach number 2 and 3, what do you see the problems? Although approach number 2 and 3 will not suffer from the memory issues because SQL has resolved those issues in the group by. SQL doesn't, SQL take care of, I mean any database takes care of doing the sorting using disk rather than memory. While you create indexes, you don't need that much memory equal to your data. So this definitely does not suffer from the. Okay, now there is a point from Ravi. The point is it is sequential, not parallel. Very good, very good. First, yes, so that is one problem. So all Ravi is saying that these approaches could be made faster by doing it in parallel. While one portion, one program is reading from the disk, and that time when the CPU is free, other program can do the sorting. Good, brilliant. Okay, Randhir is saying it will be CPU intensive. Good, good. This is also a very good point. Now, if you are able to do it parallel, then it will be fairly CPU intensive. What else? Do you see any other problems? What do you think when the data grows when we are doing this? Okay, and this file is of say 50 gigabyte. Okay, for a 50 gigabyte, I'll just switch to the same problem. Okay, so my question is for for a file of 50 gigabyte, which out of the four commands, if running parallelly or independently, will take most time? Anyone? Cat will just read the data from the file. SCD will replace the line by line, and sort will order lines. Okay, whatever is given to it, and unique will find the unique for a 50 gigabyte file. Or let's say, let me just make a little bigger. Say 500 GB file. For a 500 GB file, who will take the maximum time? All right, all right. Let me take a step back. Now let me add one hint. We are using hard disk drive now, and 1 gigabyte IO, 1 gigabyte read from hard disk drive takes how much time? All right. Siddhar says 5 seconds. Let's assume that it says 5 seconds. And there will be also hint number 2, there will be 500 gigabyte data written to the disk, because we will split it into 1 GB each. Now, yes, all of you are right. Most of the time is going to go in sort command. Perfect. Not because sort will take lot of time, but because IOs will go into I it will most of the time will go into the IO. All right. Now let me change a question a little bit. Same question. Okay. Same question. Which of the following will take most of the time? A, CPU. B, RAM. C, IO. Okay, most of the time will go into CPU computing, real computing, and C is disk IO, and C is STD out, and D is assembling the assembling the commands. Correct. The most of the time is actually going to be consumed in B. So these both approaches, second and third, are going to have. Okay, so CPU is not going to be the bottleneck. It will be the disk IO which is the bottleneck, because sort will split the data, will try to write to the disk and also read from the disk and so on. All right. Therefore, CPU will be actually free. The most of the time will be consumed in writing to the disk and reading from the disk. All right. So the problem with the approach number two and approach number three is, other than these two problems, where were I think I had written, yeah, these two problems called it is sequential and not parallel, and it is CPU intensive. The disk IO, it most of the time will be consumed in disk IO. So these things will become the bottleneck. So the moment data starts going beyond the RAM size, generally, generally when you are sorting a data, okay, make a note of it. Heuristically, when your data grows beyond 15 GB, the getting it done, getting it done over cluster makes sense. Okay, so when the data starts growing beyond few gigabytes, the RAM will become a problem, and therefore the time taken will start increasing. And the following will become the bottleneck. CPU will become the bottleneck, disk speed will become the bottleneck, and disk space will become the bottleneck. Okay, provided we use multi-threading and we use a parallelization mechanism. Susan's question is, what will happen if we do not restrict the sort to 1 gigabyte? Anybody can answer this? What will happen if we do not restrict the sort to consume only 1 gigabyte RAM? Okay. The, the good part is that it will try to consume the whole RAM, but it will not cause memory overflow. All right. The other processes won't get resources. That is Ganpati. Good, very good answers. And Rishidhar says RAM usage will increase. Veena says system will slow down. Brilliant. And it will crash because not of enough RAM. No, it won't. This sort command is clever. Had it been our program, that there could have been the memory overflow. There'll be, in case of Java, there'll be this error called heap overflow cannot locate memory. Okay. Bala says that system will go into hung state, and sort might try to use beyond RAM available. So sort does a bit of a calculation. It actually tries to guess the RAM size available and tries to do it. But still, it will consume too much of memory that there will be no place for anybody else. All right, so good. Very good set of questions. All right, now so first we try to use our rudimentary Java program or your programmatic approach, which of course has the RAM problems. Now we change the approach to SQL, and other approach was using Unix and sort command with 1 gigabyte restriction. Now we were able to do it really well, but CPU, disk speed and disk space is becoming the bottleneck. Now what should we do? Anybody? distribute the work. All right, let's distribute the work. Okay, now let's try to distribute the work to multiple machines. All right, so we will try to do that. Billy and Dwala, thank you. So let's try to do the distribution of work. Let's imagine a kind of a system like this. You have got two machines, machine 1 and machine 2, available for you to do these sorting operation. Now what you do is you split the files, okay, to a size that fits the memory. Okay. Now let's say you have two machine, machine 1 and machine 2, and you split the files such that you to the size of RAM. And now from this launcher, the launcher is where you are sitting. Now from the launcher, what you do is you start sending lines or words, lines to machine 1. In the same way, you start sending lines to machine 2. Okay, so let's say 1 million lines you have sent to machine 1 and 1 million lines you have sent to machine 2. Okay, now both of these machine 1 and machine 2 are running your program which you did in the first approach. Okay, so 1 million lines are good enough to be fit into the memory, and these lines are basically being sorted using using our program which we described in the first approach, using everything in the memory. And now whatever is the result is being sent to the launcher. Okay, so machine 1 is giving the word and its count, all of the words and its count, back to the launcher in an ordered format. This is sorted format. Okay, so Ray comes before Sa, and so on. Similarly, half of the 1 gigabyte data has gone to machine 2, and machine 2 has also given you the result. Now the launcher will merge the two. Make a note of that we are merging two sorted inputs, two inputs which are already ordered alphabetically. To merge such kind of inputs is actually very straightforward. Do you agree with that? Merging two ordered input to generate another to generate ordered output is straightforward. Do you agree with that? Yes, no? Yes, Sridhar, that's what we are doing. You're right. Divide the files into small ones, assign to different machines, and get the work done individually on machine 1, machine 2, machine 3, machine 4, and get the work returned to you at the launcher. And then, since all of these files are ordered, it is easier to merge them easily. Therefore, the sort command, sort minus m, does exactly that. If you have lots of files, thousands of files, which you want to merge together, and these all thousand files are already sorted, then you can use sort minus m. It will not really sort, it will just merge all the files you provide as arguments to it. Or let me try to demonstrate to you. If I'm in your place and if I have to sort minus m, okay, how does that algorithm work? Okay, now imagine you are standing, imagine there are two queues in which people are standing in their ascending order. Okay, imagine two queues in which people are standing in ascending order in both the queues independently. Now you want to merge these two queues easily. So the easiest way is you go in front of the queue, face all the people, turn your face to the people, and then pick the one from the head who is shorter and put him into the new line, and then you keep on doing the same thing for all the people. Let me show you. Let's imagine that this is the this is the one queue, this is one queue, okay, and this is another queue, okay. Now both the queues have the data sorted in increasing order. Now if we have to merge these queues, all we have to do is go to the head. Out of the head, who is smaller? Both are equal size, so pick both of them and put them in the new queue. Now again, you compare the head of the two. Okay, who is smaller? One is smaller. So you pick one and put him into the new queue. Again, compare 2 and 1 and you find out that one is smaller. Again, you compare 2 and 1, you got 1. Okay, now out of these two, again you compared, right? Therefore, you just pick 2 and put him here. Okay, now out of these two we have this. Okay, now you can see that out of 4 both are equal, we pick both of them and put him. All right, so you can see that we are easily able to pick up and merge these two. Sounds good. And out of 19 and 90, it is 19, and this is 22, and now 90 90, and again compare 91 and this, we pick up 91, and then when nothing is left in one queue, put remaining values from other queue. So we were able to quickly merge the two queues without too much of computation. Now the most important part you need to understand is that this operation was very less intensive. It was not equal to sorting the data. Try sorting these many numbers manually. It's actually intensive work. But merging was very simple and straightforward. Okay? In mathematics terms, in programmatic terms, the time consumption of sort operation is directly proportional to number of elements into logarithm of number of elements, which is really huge. And here the time consumed in merging the element was proportional to total number of elements. That's it, no multiplication. Therefore this approach is sustainable. Does it make sense? So Sridhar's question is, but still it is taking time to sort two files. Yes, and that is why we have delegated that work to multiple machines. So the actual heavy lifting is done by individual machine, and we at the launcher are just merging the data returned by these machines. Is everybody with me? Yes, and it is done in parallel. Yes, thank you, Ina. Yes, it is done in parallel. Both machines are working parallelly, consuming their own CPUs and consuming all the RAM and giving the launcher the result. And launcher is waiting for the output from both the sides and merging them continuously and putting them into the disk. Sounds interesting to you? And this is how we could actually, when we long back we were working at DShaw, one of the framework which we had designed was on the similar lines. And in some way we, when we study Spark, it is actually similar to this kind of mechanics. All right, but there are few more things here. Do you see any problem with this? This is called external sort, using external machines to sort. And do you see any problem with this? All right, Sridhar, you got your answer? Ravi, don't worry about map parts right now. We will talk about it. Now, Susan's question is, why only 2 and 3 to find frequencies, and why not Java? We could have used Java as well using external sorting without using hash table. All right. The hash table one, which we were the first approach, we was kind of in Java. Okay, so here are some of the points which you are actually raising. One is, what if the problem with this approach, problem with this approach, problem with this sort approach, okay? Problem with sort approach is, if the file merge file is large, what will happen in that case? Who will assign to the machines, and how many? Okay, these are all actually the problems. Although I'll tell you in quickly. So who will assign the machines? We will have to, the launcher has to take all these things into consideration, and and therefore it will be a problem. Okay, so what else do you think are the problems with this external sorting strategy? Anyone? All right, Suresh says that it will be a time delay. Good. Good, excellent. Thank you, Bala. Bala says if one of the machine goes down. Brilliant. All right. Yes. It'll be time consuming. That's correct, Suresh. All right. Veena says, what if one machine finishes sorting way, way, way early? Brilliant. It has to wait for others. Yes. Brilliant. Any other problem do you see? Did you notice that launcher was sending the data to machine 1 and machine 2 and over the network? And again, when machines were finishing the work, they were sending back the data to the launcher. Bala says, if the network has an issue, yes. So it will be, thank you, Chintala, it will be network load. Brilliant. Okay. What else do you see? Great, great. So those are the problems with this approach. One is, time is consumed in transportation of data. For each requirement, we will have to stitch a new solution, and we will have to write a special purpose program because we are doing this distribution ourselves. It requires a lot of engineering, meaning you have to take into consideration what if one machine goes down, what if one machine finishes early, or what if other machine is very, very slow or very, very fast. So it requires a lot of engineering to get it right, to do things in parallel, to do things in conjunction. It takes a lot of engineering. Also, there's a lot of time consumed in transport of data. And therefore, MapReduce is one of the best solution for this kind of computing. Okay, and you will understand why is MapReduce better than this. Even though this approach as well as MapReduce both have have multiple machines. The difference is, in case of MapReduce, the time will be consumed only once. If you upload the data onto HDFS, the data that you want to process, the only time that will be consumed is only once. And most likely, when you churn this kind of big data files, there would already be in the disk, in the HDFS. Therefore, time consumed in processing huge data is zeroed down because the computation happens near the data. Therefore, most likely our computation, our individual word count, individual launcher on machine 1, machine 2 already might be having this section of the data. Okay, and therefore it will basically machine 1, machine 2, machine 3, they will not need any transport of the input of the data. And machine 1, machine 2, machine 3, and so on, all of them will work together parallelly, reading their local data, because every machine in case of HDFS, every machine might have sections of the data in form of blocks, and all these machines parallelly will read the block, compute the frequency, and give it to the launcher or give it to some other machine where it get all combined together. All these outputs get merged and then saved to the disk. Susan's question is why MapReduce is called MapReduce. Okay, you will get to know it just in 10 minutes. All right, now moving ahead. So we have established the reasoning behind MapReduce. Okay, the programmatic approach was consuming too much of RAM. The SQL and Unix way was not was too intensive on CPU and disk IOs, while our launcher way or the external sort way was consuming too much of network. And and therefore, best way probably is to use a MapReduce like a solution where data locality is there. Okay, where data locality is there, and you don't have to code too much for sorting. You don't have to do anything related to the sorting. And therefore, if you think about MapReduce, as we will see very soon, MapReduce is basically a huge sorting engine. All it does is sorts the data. Okay, sorts the data available locally on the same node. Now, coming back to what we were starting, now let's understand what exactly is MapReduce. Okay, a MapReduce is a programming paradigm. All right, also it's a framework which does a lot of heavyweight lifting for you. Okay, but for you as a developer, it's a programming framework which involves, the objective of such a framework is to help you solve big data problem. Okay, and specifically sorting intensive problem. If your problem cannot be converted into a sorting problem, then MapReduce will not be of much use to you. Okay, okay, so it's a programming paradigm. Although it's a framework underlying, there is a engineering, lot of engine. It's an engine underneath, but for you as a developer, it's a paradigm. Just like SQL is a data filtering, data churning paradigm, the way Unix filters are a paradigm. Similarly, MapReduce is another paradigm to churn the data. You have to code two functions. One is called map function, other is called reduce function. The objective of your map function is to tell the engine that our data will be sorted based on this key. Essentially, converting a line, converting an input record into key value pair. In our case, in case of word count problem, the key was the key was individual words, right? And there was no value because we wanted to sort our data by words. All right. And reducer is something, so whatever, whenever you have to clean up our data and specify that my data needs to be ordered by this particular key, that work is done by the mapper. So you will write your mapper code which will take an input record and return key and maybe a value, and maybe a value. All right. Now the reducer aggregates all the values for a key. So once once MapReduce has done its job of of sorting the data. So before Hadoop starts sorting the data, it will execute your map function on each record, each input record, and whatever your map function gives as output, it will sort that, and the basis of sorting will be the key of that record. So your program will output key value pairs, and that key value pairs will be gathered by MapReduce, and all of such data will be sorted by this engine. And once it has finished the sorting, then for each key it will bring all the values together, and for all these values it will execute your reduce function. So since your reduce function is being called for all the values, the your reduce function signature has to be that it will take an array of values as an argument and return a single value. So mapping means converting converting the input record into something else, mapping one input record to another record, and then reducing means reducing so many values into a single value. All right. All right. So this paradigm is not anymore limited only to Hadoop. The whole idea of MapReduce came from Google MapReduce framework for massive parallelization. So there was this paper written by Google, where it was written by Sanjay Gemawat and Jeff Dean, in which they had described the process of MapReduce and how they computed the page rank of the whole World Wide Web using MapReduce on a massively parallel scale. And when I say massive, it's 500 terabyte data. Okay, so coming back to what we were talking, it's not only this particular map reduce paradigm is not only limited to Hadoop. It's also in Cassandra, HBase, MongoDB, and CouchDB, and many more similar systems. It's the same paradigm adopted by many people. Also, in some way, the similar paradigm is also there in case of Spark. Although one more thing you should keep in mind, the MapReduce, the literature of MapReduce comes from procedural language or functional language. We call them functional language, such as Python, such as Lisp. They had even Perl had a concept of MapReduce long ago. Okay, so everywhere the definition was similar but not identical. All right, let me try to just show you a very simple signature of MapReduce. All right, all right. So generally, your MapReduce function will look like this: define my map, and this is my record. Okay, this is my record, and here will be your code, and this code at the end of it has to return some key and some value. Okay, and Your reduce function will be looking like this: key and array of array of all values. Okay, these are the variable names, and you will be returning something like key and some aggregate function on array of values. Okay, all right, now you can understand that here the duty of map is to convert this into key value, and duty of this is to convert into key and a single value. All right, let's try to see if I had to implement the same thing in Python, what would I do? Okay, I will write my map function, okay, which will get one line at a time from Hadoop, and this guy will simply return, split, okay, for word in line dot split, okay, line dot split, and it will basically you know mm, okay, you can think of it, let me just do print, okay, print word comma 1. So this is my key and the value, and my map is printing that. Okay, it's producing key and the value, or you can say yield, right? You can say yield. All right, similarly, or here also we can say yield, not produce, because not return. All right, now my reduce will be, in case of this, I'll get what? Word and something like, it'll be array array of what? Ones. And what will I do here? I will return array I'll return sum of array. That's it. Now this will magically do a lot of things for us. So these are the two functions which we define as part of our MapReduce program and bundle them into this jar, the jar you saw earlier. Here I'm writing in Python, but you write it in Java generally. Okay, and once it is done, you bundle it nicely, hand it over to Hadoop jar. It will execute your map function and reduce function, and whatever is the output, it will save in the HDFS folder. All right, now let me take your questions. Sounds good to you? The mapper and reduce, there are a few more things I want to tell you here. The mapper and reducer can be written in Java and can be written in many other languages, can be written in Shell, Python, or any other library. Okay, we will show you how can I write MapReduce using Shell. Lucky for us that some people have written something called Hadoop streaming, in which you can pass any program as mapper and any program as reducer. All it need to do is produce key value pair. All the mapper program need to do is produce key value pair in tab separated format. That's all. And the program can be considered as the mapper, and we can consume it using Hadoop streaming. All right, now let me take your questions and then we take a break for 10 minutes. Or should we take a break now and then take your questions? Yeah? Should we take break now or after the questions? All right. So everybody wants a break first, and then also it will give you more time to think about what we have done, and also write your question nicely. So we'll have a very healthy discussion, and then we go with more examples. All right. So let's take a break for 10 minutes. Back by 10:15 p.m. IST. All right, so I'm back. Should we start now? All right, should we start now? All right. All right, so let's take one question at a time. So I think I've answered the first one. Why is MapReduce called so? Okay, because of MapReduce already meant something like translating the input data into something else is called mapping one input value to another input, and reduce is combining multiple values together, producing a single value. That is called reducing an array into a number. All right, now Bala's point is that so MapReduce is used only where sorting is involved, not anywhere else. Actually, ma- so if you do not have a reduce, so you can also have a program. You can have a program which is MapReduce program without the reduce. Okay, without the reduce, meaning there is no sorting involved, and all you want to do is convert input data from one form to another. Even though we are not doing sorting, but we are just translating data from one form to another. Okay, therefore MapReduce paradigm can be exploited or can be used in the cases where we don't require the sorting. Okay, in the cases where we just want to translate one input block or one input file into another file. All right, that was Bala's question. Okay. Now Sridhar's question is map is order by and reduce is group by. Not really. Map is actually map is select statement. You remember select where we used to say select A plus B. So this is the operation we are doing on the input, and then group by is being done by Hadoop by so I'll say group by is done by Hadoop, okay, and then reducer is basically equal to saying sum of some value. Okay, I think there is a explanation on the next page. All right, I have an explanation on next page here. So this is how it looks like. Okay, so yes, you can actually visualize your SQL in this form. So when we say select word count star from a table group by the word, right? So if you think in terms of MapReduce will do the job of select here, basically, and marking it like we want to order the data by word. Okay, that's what we are doing in map. While reduce is basically an aggregate function, which is count star. Going back to our problem. So Veena's question is, can you mention an example where we have key and the value? Okay. Can we? have an example where we have key and the value. Okay, let's give it a thought. Imagine that you have a column called section. Let's say there is, you have marks of each section. Okay, and sorry, student. Okay, student, and student, then we have subject, and then we have marks. So a student got B marks in B subject, it got 10 marks, and A student got C in C subject got 20 marks. Now if we have to compute total marks of per student, total marks per student, what do we need to do? We need to write something like select student, comma, sum of marks from my table, whatever table name we have, where where sorry, not where, it's by group by student. All right, if the same thing is written using MapReduce, so MapReduce will get a row at a time. Okay, that you should note when we say record. So we'll have define my map, and we will get a row as the input, and it will yield, or it will give out the row, and it'll give out what, student and comma marks. Okay, so row dot marks and row dot student, just to make the symbols simple. All right, that's it. Now in case of here we will write my reduce. Okay, in my reduce we will receive an array of array of marks, and all we need to do is return sum of array of marks. Sounds interesting? So this array of marks, the conversion from bringing together all marks and converting into array, is the duty of Hadoop framework. Okay, I'll show you diagrammatically, then you will get a better picture. So Naveen's point is, do we need to return student as part of reduce function? Generally not. You don't return the student, but it is up to you, and that whatever you return from here will be stored in the file system. All right, sounds good. Now next question from Ganpati is it right to say Hadoop does the sorting? Is it right to say that Hadoop does the sort? MapReduce uses HDFS and sorts. So no, MapReduce does the sorting utilizing yarn. MapReduce has the algorithm of sorting the data, and yarn executes that algorithm. Okay, now MapReduce tells to the yarn that here is my algorithm for sorting the data, and here is my mapper, this program which will run the mapper. So yarn doesn't know anything about mapping and reducing. Yarn doesn't know that there is sorting going on. All yarn knows is that MapReduce has asked me to execute these programs at these locations. While MapReduce asks Yarn that, hey, can you tell me which machines are free and are near to this file, or give me the name of all the machines where the blocks of this file are located. That it asks Yarn, and Yarn further asks the HDFS and also consults its own configuration and node managers, okay, and gives the information to MapReduce that, hey, your file is this, fine, we have got these machines free, do you want to execute your work in these containers? And MapReduce say, yes, please execute this logic here and that program there. Okay, so Yarn doesn't know anything about mapping and reducing. All it knows is that it is supposed to execute some program somewhere. So make sense, Ganpati? Can mapper and reducer be compared to functions? Yes. Both mapper and reducer are basically going to be classes which implement certain basic, certain abstract, certain classes, and override map and reduce functions. Okay, so effectively mapper and reducers will be the function in Java. I will show you how they will look like. Okay, so Ganpati, are you on the same page? Or yeah, so here is a follow-up question, and this is a nice question. It is also using container and application master for MapReduce. Exactly. Yes. All right. All right. Now, Randir's question is, which language is commonly used for MapReduce? It's very difficult to say. So I'll explain you this way. I started my MapReduce in Python. Okay, although I had been programming half of my life in Java, but I started MapReduce in Python because that was quickest way to get started. Okay, and then when we had to do more detailed and fast stuff, then we moved on to using some parts in Java. There are some portions in which in MapReduce there are some portions which can only be done in Java. Those are like in very advanced phases. So for those kind of things, we moved to Java, but most of the work we had done in Python. Okay, I would strongly recommend that you focus on what you need to get done. In case it is something really advanced, you go for Java. Otherwise, the Hadoop streaming, which we will discuss now, is good enough for you. Okay, so Ravina's question is, so can the mapper and reducer be in different languages? Okay, this is a difficult question to answer. So can mapper and reducer be in different languages? In mapper in Java and reducer in Python? Yes, using Hadoop streaming. I'll show you Hadoop streaming and then you will have an idea. We'll start the whole thing with Hadoop streaming. Okay. All right. Now, this is Sushant's question is how this algorithm will help in other generic situations. Can you please give us one more example? I will show you some. Really good stuff. Okay. Um, Map reduce for matrix multiplication. All right, looks like I don't come here in the top one. Yeah. Okay. So here I have tried to multiply two big metrics using MapReduce. The only difference I have done is instead of displaying the matrix like n by m, I'm using row column value, I, j, and value in this format, meaning three columns and many rows. And using that, I've tried to write the matrix multiplication here. You should have a look at it, but only after this discussion. Okay, let me think of some other example. Okay, so this was clear to you, right, when we did the summation of this, Sushant? We did this, right? We wanted to compute the marks per student. All right. Let me think of some more. There are many scenarios. We will go into more and more details. All right. Okay. So let me just give it a thought. All right. Let's take a very different example today. Okay. Let's take a very different example. The example is we want to count number of characters. Total number of character. Count total number of total number of maybe vowels. Okay, we want to count vowels. Can somebody help me? There is a big file. We want to count number of vowels. How many times A has occurred, W has occurred, I has occurred, and so on. I think this is easier. Let me just Naveen says that can we return an array from mapper as value eh, versus a single value? Yes, you can return anything you want as a value. Okay, but you have to take the same thing in the reducer. Okay, shortest path algorithm and calculating routes, that will be little too difficult for this session, but I can try it in my free time. Okay, or what do you do in general life? Let's say, so this one is clear, right? All we have to do in our mapper, okay, all we have to do in our mapper is here. Okay, here just like we were yielding, we will go over each and every character and we will say how many times A has occurred and how many times E has occurred, and so on, right? And so on. And in the reducer, we just sum it up. Okay, so here the vowel, and we will get one, I mean maybe 1010 comma 10, and so on, 1010 and something like that. And here we just return the sum. Okay, we'll just return the sum of this array. Okay, this is simple. Let's say we are trying to do a grep. You have question problem statement. This is interesting. I think this is going to be interesting. You have a million. No, so you have 100 terabyte of data. Okay, and you want to output the lines containing a particular word. Okay, all right. So Vina's point is, why do you need to do each vowel separate? Can't we use counter and increment it for you? Yes, you can do that. You can do that. But while yielding, you have to give out for each vowel, so that while mapper is running, it will bring for each character, maybe for B, for C, you could yield. Okay, and here this is how you will compute the character frequency in the complete text. All right, Veena. Because see, this mapper is going to run on all the machines containing your data, right? When it runs on all the machines containing the data, every machine will have some value for A, some value for B, some value for C, and so on. This needs to be brought together. And after bringing it together, what should we do with all those values of A, B, and C? That is decided by the reducer. Okay? All right. So almost now I think I have covered the most of the situation. Here, this problem, I think we should take this problem once I give you a visual walkthrough, and then we will take this problem again so that you have a better grip of the complete MapReduce paradigm. All right, I'll take this in a while. All right, just give me 10 minutes. All right, Bala's suggestion is, can you show some examples, something related to data, example SQL with different data types? Okay, all right. So whatever we feel great about churning the data, we will take those examples. All right. So let me try to show you some visual steps visually, as in what's going on inside it. All right. All right. Stay with me for next 10 minutes and good. So this is what goes on inside a mapper reducer. While we do the word count, imagine that our input line, each line is, let's say first line is sa re sa ga. Okay, that's our input line. The function, which is our mapper, will get that as argument. Sare Saga is the input here. This is my input line. Now, for each word in the input, what it will do is it will print key and the value. Basically, it is telling the framework, hey, this is my key and this is the value. So, and based on this, what we get here is Savan, Revan, Savan, Gavan, and so on. And this invisible line, you see, this dashed line is what is done by Hadoop. So Hadoop takes this output and converts it into something like this. It basically groups it by the key and brings all the values into an array. That's all Hadoop does here. Hadoop takes the output of your program and groups it and brings it here. And once it is there, it reduces it. So whatever function you write as reduce will be executed on each of the array. That means reduce function is going to be called 3 times. One for ga, one for re, and one for sa. And what does your reduce function do? It converts it into summation. So it becomes 1, 1, 2, right? 1 plus 2. Now, here the important part is other than grouping, this data is also sorted. Ga has come before Re and Re has come before Sa. Alright, so this is the sorting part of Hadoop. Hadoop takes your key value pairs, sorts them, and runs through the reducer. While you can turn off this whole mechanism altogether. You can say, I don't have any reducer and I don't want any reduce phase. This whole process of sorting and calling the reducer is called reduce phase. You can tell Hadoop that, hey, I only have mapper and that's all I want. So the result of the mapper will directly go to the output rather than this phase. Okay, so this phase is optional. Now, yeah. So the thing is, this function, you cannot have something like run reduce on this, different reduce for ga, different reduce for say, different reduce for sa. If you have to do that, you have to put if condition inside your reduce, saying if word equals to ga, execute this. If word equals to re, do something else. If word equals to sa, reduce, do something else. Okay, the framework says you have to give me just one function. I will run it again and again over all of the keys till and give you the result. Similarly, if there are multiple lines in the input, if there are 200 lines in the input, same map function will be called on all of those 200 lines and you will get key and value collected from all of those 200 lines. All right, now let's take a step further. Okay, let's take a step further. This was happy, this was looking very redundant. We have some line, we are running mapper, we are running reducer. What if we have multiple nodes containing our data? We had very small file, smaller than the block, therefore there was only one block. Here there are two nodes, data node 1 and data node 2, containing one block and containing another block. Now mapper will be executed on each line from node 1 and each line on node 2. If there are 200 lines here, the map function will be called 200 times here, and same map function on some other node. So your code which you wrote as map is taken to node 1 and node 2 and is being executed again and again on each line and converting each line into the key value pair. And once we convert it into key value pair, so you can see here that this is what we get in the first section, this is what we get in the second arm. here the one stage. So sa re sa ga, and then mapper converts it into sa one re one sa one ga one. Here at this stage you get this sa re sa ga. Okay, this is what you get at this stage, and this stage you get sa one re one sa one, and so on. Now at this stage this data will be sorted. Once this data get individually sorted, you get GA1, RAY1, SA1. So you can see this colored one is something done by Hadoop. And this is your code. You wrote this code and handed over to Hadoop for the execution. All right. So here, after sorting, this is how it looks, and this is how it looks. So here, at this stage after sorting, this will be the result, and here after sorting, this will be the result. Now Hadoop will merge the two, and after merging we will have ga 1 and ray 1 1 and sa 1 comma 1 comma 1, and so on. So it has gathered all the values together from all the nodes. And once that is done, then comes your reduce. Your reduce will be called on this, called on this, called on this. Okay, effectively when your reduce gets called, one array of 1, if you sum it up it'll be 1, if you sum it up it'll be 2, if you sum it up it'll be 3. All right, so the result will be ga1 ray1 sa1 and sa4, ga1 ray2 and sa4. Make sense to you now? Now let me take your questions. I have missed your question, couple of them. Now there's a question. So I will take your request, Bala. These two things I will take later. Okay. Let me first answer the questions related to the slide. Can reduce function just call array having size more than one? Can reduce function just calls array having, yeah. So basically it is the Hadoop which calls your reduce function. It is the Hadoop which calls your map function. Hadoop reads the data from node 1, prepares the record line by line, feeds and calls your map function on each line, and gathers all the result provided by you, sort it, and then once it has sorted and grouped for each key and all the values for that key, it is going to run your reduce function. Okay, I hope that is clear. All right. So who calls this merge function? It is done by Hadoop. Okay, this merge function is not you are providing right now, but you can definitely provide your own merge function. Now question from Veena is time consumed in is time consumed in reduce is less than map? It all depends from problem to problem. Okay, it all depends from problem to problem. Yeah, so all right, I think I got the question what Sridhar was asking. Sridhar was asking, can reduce function just calls array having more than one size and simply dumps all other words? Yes, you can do anything you want inside the reduce function. That is your code. All right. Veena's question is interesting question. Apart from sort and merge, is there any other operation done in between reduce, map and reduce? No. There are some more you will see. There will be some more things called partitioning and we will also see some more things like what do you call those? I am forgetting them. There is partitioner and there is a there is okay, you will see that after this. Okay, now this is a question from Randir. What aggregate function can reduce have? Any function you wish. Okay, a reduce function could be, maybe it is like min, it is max, or it may not do anything. It may just concatenate, concatenate, concatenate all values by comma and return it and return. Okay, or it just doesn't give out anything, it just return null. Okay, nobody will question. So it is all the important part is it is your program. If you have this special library, you can utilize that library. Okay, so it's the program. It's not limited by functionalities like SQL is. You can only use those programs in SQL which are provided by the language. Here it's your complete, you are in complete control whatever you want to run inside reduce. It could be as complex as, once everything is done, let's push this stuff to database. So a reduce function can actually call the database and store all the values in the database. All right. Next question is from Veena. Is sort and merge done for all MapReduce programs? Not necessarily. As I was telling you that you could tell Hadoop that, hey, I don't need sort. I don't have a reduce function. Please don't sort my data. I don't need sort. All I want is, please run my result and save the output. So after two here, these values will be directly saved in the, this will be saved in HDFS and this will be saved in another file in HDFS. Okay, nothing will happen what has happened below. Very good question, very good question. So you can, while supplying, so while supplying input to MapReduce framework, you provide the following. And this list will keep on improving this list as we understand more and more about this MapReduce phenomena. Okay, we supply a map function, we supply a reduce function, okay, a reduce function, and this is completely optional. I'm just putting a question mark to say that it's optional, and we provide HDFS file. Again, this is also optional. Now we will see more and more information going here. Parameter such as should, have, reduce, yes or no. Okay, all right. Sushant's question is, can we have our own merge function? Can we also extend existing map and reduce function? Can we create our own map? Yes, of course. You create your own map function. It is just that Hadoop runs them. You cannot change a behavior of Hadoop to run map instead of reduce and reduce instead of map. No. To do that, you will have to basically create a new framework. But map function is your own function. You do whatever you want to do. Okay, you do whatever you want to do. If you want to just convert the strings into hexadecimal and then pick up three values and run the remainder on that, you can do anything. Okay, so if you, If you're comfortable with programming, you create your own functions and hand over to the to Hadoop, and Hadoop will execute those functions as map and reduces. It's all up to you. It's all your code, your program. Your map function could be as complex as download data from internet and parse the XML, parse the HTML after downloading the web page from the internet, and in that HTML, convert that HTML into something else and save it to database. Your map function could be anything. Map function could send email, whatever you want to, whatever you can do in your program, whatever you can do in Java, you can do in your map function. You can create anything. All right. If you want to compress the data from one form to another, you can do it as part of map program. Wow, that was the next question from Naveen. Yes, you can. Who provides input to the map function? Hadoop does. Okay, we will come back to this again. We tell Hadoop that, hey, this is my file. Now it's up to you. And this is the format we are looking for. It's a JSON format, it's XML format, or it's a plain text. If you tell Hadoop that this file is plain text, then you know what does Hadoop do? Hadoop gives one line at a time to your map function. Okay? In case you have something like a key value program, key value file, it'll give you different input to your map function. We will see that there's a little more advanced. All right. So Randir's question is, can you please give a real life example for MapReduce? So the most real life example right now, the easiest one is your word count, because word count is basically an important problem which we do as part of anything. Whenever we have to find out the, whenever you have to find out these, basically whenever you want to analyze a text, you can do this. Okay. Now, so we will go into more details, and then we can do that. All right. Now, a question from Veena is, there is no existing map reduce. It is written by developer. Perfect. So yes, that is the case. There is no such thing called existing map reduce. If it is existing, then you don't need it. All right. Now, a better diagram which is provided by Hadoop themselves is this one. Okay. So your file has got three splits: split number 0, split number 1, and split number 2. Let's say your file is how much? 300 MB. Okay. So let's say your file is 300 MB. So your split 0 is 128 MB, split 1 is 128 MB, and split 2 is how much? 300 minus 2 into 128, which is 300 minus 256, and which is 44, right? So you have 128 MB, 128 MB, and 44 MB. Okay, because these are three blocks, and for each block your map function will be called on each record. Each block will be broken down into records, and for each record map function will be called again and again. Okay, if your input is a text file, for a text file, okay, having on an average 100 characters per line, meaning 100 bytes per line, how many will be there? 1 million line on an average, approximately 1 million line, which means your map function will be called 1 million times. Okay, for a text file containing 100 characters per line, which means 100 bytes per line, it will be approximately 1 million lines. And because it's 128 MB, right? So not really, it will be far more than, yeah, it will be 3 million lines. For 300 MB there will be 3 million lines. Okay, and then so your map function is going to be called 3 million times for each line. And whatever your map function is giving out, it will be sorted, it'll be sorted. And not necessarily these will be lines. These could be binary data. Let's say your file contains photos, it's a big zip file containing photos of people, and your map function is just computing certain characteristic in the photo. Okay, so map function will give out the key and value, and it will be sorted here, and then it will be taken to another machine, and there it will be merged together, and after merging together it will be passed each key and all of its values which are gathered from all the nodes will be passed through the reduce function. If there are unique if there are unique 200 200,000 keys, okay, reduce will be called 200,000 times. Your reduce function will be called on each key. Alright, and whatever is the result of your reduce function will be saved in HDFS file. Alright, so what happens in case of structured data like CSV? Yes, it is still split at 128 MB. We'll go into the details about the boundary problems, because as you must be expecting that when we cut the file at 128 MB exactly, and it will cut it ruthlessly. I mean, HDFS doesn't care whether your data is structured, unstructured, or semi-structured. It doesn't care. HDFS ruthlessly cuts the file at 128 MB. Okay, that means each record, meaning each row, each line of the CSV file might be half in one block and half in on another block lying somewhere in another Almira. Okay, so those kind of boundary problems are also solved by Hadoop by bringing data from remote, only the slightest one, the boundary one, to make the record complete so that it can feed the complete record to your map function. Okay, there's an important question, which is, can we reduce on distributed system itself before merging? Meaning what he wants to do is he wants to run his reduce function somewhere after this box. Yes, you can do that. We will show you that. Okay, all right. Oh, I forgot the name of this thing. We will go into that detail. All right, I'm just missing the keyword. It is called merging. It is called, no, I'm just missing that keyword. Yeah, all right. Now sometimes you see this flow here, it sounds like there is a single reducer phase. Okay, although the reduce function is being called many times, but it's a single reducer phase because it's being run, your reducer is being run only on one machine. So we call such situation as the total number of reducers are one, although there are so many keys and your function is being called many times, but it's happening on a single machine. The merging is being done on a single machine. Sometimes you want to do it on multiple machine. In those cases, there is a phase called merge and shuffle. Okay, so it sends some keys to first machine, some keys to another machine, and and but it makes sure that all the values for a key goes to a same machine. It should not happen that some values of a particular key has gone to one machine and some values for a particular key has gone to another. It won't be possible. Because the basic premise of group by or Hadoop is that all values for a key will be available to your aggregation function. Okay, all the values for a key will be available to your reduce function. That is the promise of Hadoop. No matter how many reduce functions are there, it will make sure that all the values for a key are always available together. All right, now this diagram is far more cleaner. This diagram shows you that there is a split. There are two reducer machines which, okay, now coming back to what we were doing earlier here. So the third thing which we can tell Hadoop is how many reducers. Okay, how many reducer nodes. This you can tell to Hadoop that hey, I need I need two machines running the reduce phase. Why? Because my reduce phase is complex and I know that. So you can tell Hadoop that, hey, please use two machines. And then the moment you say two machines and it executes the job, just after map, it starts putting the results into two buckets based on some phenomena called partitioner. Partitioner, there is a default partitioner provided by Hadoop. This partitioner's duty is break down the input into two sets. One key goes to one bucket, other key goes to the another bucket. Also note that on this another machine, if there is a same key, it will go to the same bucket. It won't go to another bucket. If let's say on one machine a key called Sandeep has gone to the first bucket, if Sandeep occurs on another node, it will go to the first bucket. It won't go to the second bucket. All right. Now, coming back to what I was talking about. So the map starts putting it into two buckets. One bucket will be carried to one reducer, while another bucket will be carried to another reducer. And same thing will happen on all the nodes. And then first buckets from all the nodes, all the mapper nodes will be combined together, and then after merging all the values for each key, reduce function will be called on each key and all of its values. And then same thing will happen on the second node. All right. Yes, so yes, key partition will be done here, Sridhar. Yep. And so Ravi's point is that, so is shuffle same as partition? Yes. Okay. And answer to this one is also yes. So is shuffle same as partitioner? Yes. Sounds interesting to all of you? Yes, Naveen, you had a question. You have raised a hand. All right. I think Naveen has got disconnected. All right. So I hope I have not missed anybody's question. Yes, Naveen, you have raised your hand. All right, great. So this is how, if there are multiple reducers, this is what goes on. Okay, we will go into more and more detail. Now again, let me try to explain to you MapReduce in terms of the group by clause. In the group by, you specify as part of group by that, hey, this is my key on which my data need to be sorted, and these are the input date values which we want. So group by is sort of equivalent, group by clause is equivalent to your map function, because in map function you provide two things. One is on what basis the data need to be grouped, and second, what is the value you are looking for in the output. So kind of group by and part of select goes to the goes in the map, while the reduce function is equal to the aggregate function you use here. All right. So basically, map reduce is sort of really powerful group by clause, where for specifying on what basis do we want to provide group by is configurable, is highly programmable. All right. So I think we should try to solve more questions. Can split and merge file will be in the same node? Split and merge. All right. Where were we? Okay. Which one are we talking about? You know, this one, split and merge. Okay. You mean to say that, yeah. So this is an important question. So here, can this machine and this machine be same, as in can we do it on the same machine? Yes and no. It all, I mean, if you think in terms of yarn's behavior, so when MapReduce start, it will tell the yarn. MapReduce will ask yarn that, hey, how many blocks do we got? Okay, these are the blocks. Okay, give me the containers close to these blocks. Now yarn will give that, okay, these are the three nodes closer to your three blocks. Now fine, let's execute this particular logic in these three containers. Now, and parallelly execute this particular logic in that container. Give me two more free nodes. Give me two more free nodes closer to this data which you have just given, closer to my files. Now yarn will give two more nodes. Now it has got total five nodes. Now based on what yarn gives, it will execute reducer and mapper accordingly. Maybe if you don't have more than three nodes, then it will run the reducer on the same nodes. There is no alternative available. Okay, so it all depends on what are the free nodes available. But generally, reduce node is generally different from the data node if you have more nodes, because the reducer node, because while you request for reducer node, your other nodes are busy doing the mapper portion. Therefore reducer node will be the free node. Okay, that is the possibility of having reducer node and mapper node is very low. All right, now let's get back to the problems which we were trying to solve, and then I'll explain to you the assignment. And the assignment is little too aggressive. All right, now let's try to do a couple of things. Okay, I'm just trying to think what all could be done. Okay, okay. So yeah, I could actually do a couple of cool things, such as computing the value of pi, computing the area of something parallelly on hundreds of machines. Where is the graph line which we wrote? I think it's far above. Yeah. So let's try to do this first. So we have 100 terabytes of data and we want to output the lines containing a particular word. Okay? That's all we want. You know the graph. Let's say you are in production environment and what you want to do is just find out the lines that contain keyword called error or all those lines which begin with the keyword called error. All right. So what to do in these circumstances is very straightforward. In this case, you don't require any sorting. Therefore, there is no reduce function and hence only the map function would be there. So all you will do is define my map. Okay. Here you will get the line and you will basically say if if line contains if line contains my line begins with, okay, if line begins with error, okay, and we say yield line and we'll say null here because we don't want anything and otherwise don't yield anything. That's it. So it will, after it runs, it will prepare the output which will contain only only the data having this line, nothing else. Okay. So why it is important? Because the problem here is not I CPU. The problem here is IOs. Why would we want grep to become the map reduce? Why? Because it is a too much of IO intensive. It will take around, on a single computer it will take around 1000 into 1024 into 1024 into 5 seconds. These many seconds it will take on one machine, and which is close to couple of hours. Okay, that's why we want to get it done parallelly on multiple machines. But if you think, if you have thousands of machines, it can actually run on thousands of machines parallelly, giving you the results. All right. Now, second question is, can you show some examples, something related to structured data with different data types instead of searching? Can somebody quickly give me an example? I will just do this one. Okay. So the question, let me just think about some question because most of the questions which I've thought about, I've put all of those in an exercise. All right. Anyone? Okay, so let me try to do something really useful. You have millions of files. Okay, you have millions of files, and you want to find out the duplicate duplicate files. Okay, you have millions of files in your file system, and what you want to do is you want to find out duplicate files. And now assume that each map function gets a file name at a time. Okay, or in other words, you are given a big list of files. You're given a big file containing the name of all the files, and you have to find out which are the duplicate files. I mean, it's a real example. You must be having hundreds of gigabytes of music, and you want to find out duplicate music files. Is that good? Is that good question to all of you? All right. So let's say you downloaded half of the internet and found out that there are and downloaded all the files into HDFS. Okay, you downloaded all the files into HDFS and saved that. All right, and in the meantime, you also prepared a big list of all the files which are there in the HDFS, and this list is what you want to operate on. So what you want to do is in the map function you define. So this is the file name. Okay, this is the file name, and in the file name we'll say from HDFS. Let's imagine for time being we are having some HDFS file. So we create HDFS file equals to you know HDFS dot file, and we provide the file name. I'm just creating a hypothetical API. All right. Now from this HDFS file handle, we say get. Okay. What we do is we we read that in the bytes. Okay. So we'll say HDFS dot file dot read all. Okay. So let's say we read the content of the file. Now we will compute MD5 sum of that file. Okay, MD5 sum is an important criteria because MD5 sum is very difficult to uh, two files having the same MD5 sum is very difficult to be similar. So we compute MD5 sum. This is a checksum of the content. After this, we prepare our own variable called key, in which we say hdfs dot file dot size and give the file name, get the size, and then append it with say colon, and then append it with MD5 sum. Now this is our key, and there we yield key and the file name. Okay, key and the file name. Now here, this is what our map function looks like. So our map function is going to be called on each of the file name, and it's going to read the data from HDFS and then compute MD5 checksum. And once it has done that, it will store that, it will prepare a key and give that. So all those files which are identical, their content size as well as the MD5 sum will be same, and hence they all will be together. So we'll have something called reduce, where you'll get a key and array of file names, and let it just return concatenated concatenated let's say concatenate array of file name by comma, and that's all it does. So reduce function is not doing anything, it's just concatenating the file name with a comma and returning. Is that clear to all of you? So what we did was we computed the checksum. Checksum is a signature, okay? Or let me just make it a little simpler. Compute signature, okay? There are standard library which compute the signature of each file. Signature is very small number that represents a unique file generally. And we are combining the signature with the size of the file. No? Hello? Am I disconnected? All right. So Vina's question is, do you mind writing the code in Java? I do. I mean, if you write in Java or you want me to write in Java? Vina, you want me to write in Java? Okay. So I'm trying to write in the most simple language. So here I'm defining a function. Okay. Let me just write, sort of you can think of it as void map. And I'm saying this is the function, put a curly bracket here and put a curly bracket here. That's it. Is it clear better now? These are not functions. These are just something which I've cooked up right now. The API we will show you later. Actual one. All right. Now, good, good. I hope this code is clear to you. All right. Similarly, here you can say void reduce and this. And actually, please note that the exact Java API I'll show you later. This is more like a pseudo code. I'm doing it for you to explain you the concept behind map reduce. The exact semantics we will consider in the next session. Okay. Now, Randhir's question is, where do you find list of library functions used in map? Any Java library or any of your Python library can be used. There is no specific library function. Just that if you are trying to access HDFS, you can use HDFS API. You can look at the HDFS documentation and then call the HDFS from within your map function. Okay. All right. Now the reduce function did not give the duplicate file. Now please note that all these files which it's concatenated are actually the files having the same key, meaning all those files whose signature as well as the size are identical. Okay, because for those the key is same. That means size as well as the signature is identical, right? Because key is composed of the size of the file as well as the signature. This is the signature. All right. Therefore, automatically Hadoop will bring all the duplicate file together. All we had to do is generate the signature and the file name. Does it make sense to you now, Ravi? So after map has finished its work, these keys, all the file names having the identical keys will be brought together, right? Yes. What if there is only one file name? That means that file is unique. There is no other file name. And while you are cleaning up the program, which might be deciding on which file to keep, which file to delete, can do that. Or in the reduce function, you could do something like cleaning up job. You could write things like, cleanup. And what does cleanup do? For I equals to 1, I less than length of this array, okay? I plus plus delete file, okay? And delete file. So except for the 0th file, delete every other file. Reduce could do these kind of things. Now it makes sense to you. I think I've deleted somebody's question. uh, I could, because I just by mistake clicked on the delete button. What is the, all right? Sushant, do you get the answer now? All right. Is this example clear to all of you? All right, great. So now there is an assignment for all of you. First one is very simple. Find the frequencies of the letter. The way we found the frequencies of the word, find the frequencies of the letter. See in the KMS, that is a better example. There you will find this under my courses, the assignment for today. Where is that? Not this one, I'm sorry. So first you have to justify why do you want to use and when do you want to use MapReduce for counting the letters. Okay. So here in the session 2, you can open the assignment. So you can open the assignment and let me just jump to the first question. Thank God I've not put my answers here. All right. So to find the frequencies of the letter A to Z in a huge text of few gigabytes, do you need MapReduce? So you have to write your reasoning whether you need MapReduce or not. Also explain what will you write in MapReduce for computing the letter frequencies. Please note that this question will be used multiple times in future in order to make in order for optimizations. Okay, so make sure that you write just whatever comes to your mind, as in whether you want to write in proper programming language in Python, Java, C++, or in plain English or in some pseudocode. I would prefer a pseudocode for this particular case. I mean these exercises. Now second question to all of you is, Find the anagrams in a huge text. You are given a very huge text and you have to find anagrams. What does it mean by anagrams? Anagrams is the different arrangement of letters in the word. The different arrangement of the letters. It's like text twist. Okay? You just rearrange the letters in a word and it becomes the anagram. Anagram does not mean reverse. Okay, anagram means anagram. So, for example, cat, act, and tech are the anagrams. So you have to print the word and the anagram. All the anagrams you have to bring together. Like after this, we got cat, tech, and act as the output. Okay, so you have to think about a strategy so that all the anagrams come together. The way we built a strategy of deduplicating the files. All right. Next question is, this file contains the DNA sequences of people. Find all the people who have same DNA. Okay, you have to find the people who have same DNA. You have to bring together all those people who have same DNA. For example, ACGT, which means user 1 and user 4 have to be brought together, while user 2 is alone. User 3 and user 5 have same DNA, ACG and ACG. Therefore user 3 and user 5 we have brought together, while user 6 is also alone. This is what we are expecting in the output. Now, there is the fourth question. The question is, there is a file that contains DNA sequences of people. Find all the people who have same or mirror image of the DNA. For example, this is a little difficult question. So, for example, ACGT and TGCA are mirror image of each other. If you read the TGCA from backwards, it will be ACGT. Okay, so user 1 and user 2, their DNA is mirror image, and user 4 also is same as. So user 1 and user 2 and user 4 have to be bring together. Maybe some scientists have told that all those people whose DNA are either exactly same or either exactly reverse. Okay, you remember isotopes where the orientation was isomers, where the orientation was identical opposite. So you have to do the same thing here. You have to bring all those users together whose DNA is either exactly same or or inverse of each other. So you have to find a technique to devise the key in such a way that all such people like user 1, user 2 and user 4 get same key, and therefore they come together automatically by virtue of group I. All right, now next question for today is, now the fifth question is really a little bit difficult. In an unusual democracy where everyone is not equal, people are voting for each other. Here in this democracy, we are given the bank account of everybody. We are given their wealth. We are told that this person is this much rich and that person is that much rich. And based on their wealth, the vote count is done. If somebody is, so basically, what we do is, we instead of counting the votes, we sum up the wealth of all the voters for a person. For example, in this case, list 1 contains the votee and the voter. A voted for C, B voted for C, and C voted for F. And there is a list 2 where we are given wealth of the persons or worth of the persons. A has got 5 as wealth, B has got 1 as wealth, and C has got 11 as wealth. Wealth or worth, whatever you want to call. So C was voted by A and B, therefore C's vote count is 5 plus 6, the wealth of A and wealth of B. So C's total vote count is summation of worth of A and B, which is 5 plus 1 and 6. And here the wealth of F is C, equal to, I mean, the vote count of F is equal to the wealth of C, which is 11. Therefore, F has got 11, while A was voted by nobody and B was voted by nobody, and therefore it is 0. So you have to devise a mechanism. Now, there are two things you should note, two things you should remember. One, A and B, if you put them in the same folder, you can feed both of them together to the mapper. Okay, mapper will receive list 1 and list 2 concatenated. You can tell the mapper that. You can give mapper a list of file together. Second, you can have multiple map reduce phase. Map reduce phase 1, in which there is one mapper, other reducer, and then second map reduce phase, which reads from the output given by the first phase's map reduce. So you can use these two pieces of information. One, you can concatenate two files by feeding them, by putting them in a folder and feeding the folder to your MapReduce program. Okay, so that way you can concatenate list 1 and list 2. Also, you can have multiple phases. So using this piece of information, please solve these 5 problems, and we will have the detailed discussion around these 5 problems. All right, does that is that good enough for all of you? So Naveen's question is the word separate a tab or space? It is up to you. Okay, generally in a file it could be tab, or it could be space, or it could be multiple spaces, or it could be multiple tabs, it could be new line, or a combination of all of these. All right, good, have a good day, and thank you. All right, bye bye, and please solve these problems and update in the system itself. Okay, we'll have the discussion on the next session. All right, thank you, Veena. Thank you, everyone. I'll have to quickly exit right away. Okay, bye bye. Have a good day.